Functions and relations. A set of ordered pairs, xy, is a relation. The domain is all of the x values and the range is all of the y values. Let's consider the cost of a first-class stamp in the United States. In 1985, it cost 22 cents, 1995, 32, 2005, 37, 2015, 49, 2019, 55, 2020, 55, and 2023, 63. So I could arrange this information into this set of ordered pairs. The domain will be all of the x values. The range is all of the y values without making any repeats. So 0.22, 0.32, 0.37, 0.49, 0.55. Now 0.55 is repeated, but I do not repeat it in the range. I just show it one time, and 0.63. A function is a relationship between inputs, or x values, and outputs, or y values, where each input has exactly one output. The output, or the y value, can be traced back to its input, or x value. Let's consider our earlier example of the cost of a first-class stamp in the United States. This set of ordered pairs is a function. Now you might be saying, wait a minute, I got 2019, stamp is 55, and 2020, stamp is also 55. But that's okay. There must be exactly one y for each x. So this is a function. Let's consider the cost of a first-class stamp in the US, but this time we're going to make the cost, the x values here, and the year, the y values. It's sort of a flip on what we just looked at. And here's our ordered pair. Now this is a relation, but this is not a function. Because if I look at the cost is 55 cents, that could be in 2019, or the cost is 55 cents, that could be in 2020. There's a repeat here. There's two different possible y values when x equals 0.55. So that means it is not a function. If we consider our two examples, in the relation, we notice there are two y values for one x value, in this case 55. And for a function, there is exactly one y value for each x. It's okay for 55 as a y value to be associated with 2019 and 2020. We can test if a relation is a function graphically by using the vertical line test. If a vertical line can cross the graph in more than one place, then it is not the graph of a function. So let's consider this graph. I can imagine a vertical line that will cross this graph in more than one place. Here's one, for example. So this is not the graph of a function, although it's a perfectly good relation. Now let's consider this graph. Any vertical line I can think of will cross the graph in exactly one place. This is the graph of a function. Here's the graph of a circle of radius 3, and you'll notice it does not pass the vertical line test and is not a function. Next we'll consider function notation. Y equals f of x. F is the name of the function and it's the rule that gives us the y value, and x is the input variable from the domain of the function. In the example, we're given f of x equals 3x plus 2. We're going to evaluate, first of all, for a, f of 4. So in part A, f of 4, that means evaluate f when x equals 4. So that it is 3 times 4 plus 2. So that is 12 plus 2, or 14. We've actually generated an ordered pair here. X is 4, y is 14. For part B, I want to evaluate f at 0. So when x equals 0, I have 3 times 0 plus 2. So that equals 2. So the ordered pair here is x is 0, y is 2. And in part C, I want to evaluate f is negative 2. So that means 3 times negative 2 plus 2. So that's negative 6 plus 2 is negative 4. So the ordered pair I've generated now is negative 2, negative 4. I can use the calculator to help me here. If I press y equals, I can put my function 3x plus 2 into the y1. Second quit gets me back to the home screen. There's a couple of ways I could do this, but I'm going to show you the table set way. If I go to second table set, I want to make sure that the independent variable, which is the x variable, is set to ask. So I'm going to hit enter for ask. Do not change the dependent variable. And then say second table. If you have anything in there, just hit the delete button. If I put in 4, this will give me the value 14. If I put in 0, this will give me the value 2. And if I put in -2, now don't put in -2 or subtract 2. The calculator makes a difference between subtraction and negative. So put in -2 and I'll get -4. So I have the point 4, 14 as I found earlier. And then I have the point 0, 2. And I have the point -2. Y is -4. Now we are asked to evaluate the function f of x equals x squared plus 1. F has the input x plus 2. So we have to substitute the input value, which is now x plus 2 instead of x, everywhere we see x in the function. So where we see x in the original function, we have to now insert x plus 2. So I have f, I'm going to use different colors. Now my input is x plus 2 equals x plus 2 now instead of x. What the function does is square its input and then add 1. So now I'm going to let go of the different colors. So I have x squared plus 4x plus 4, when I FOIL this out, plus 1. So this function is going to be x squared plus 4x plus 5 at the value x equals 2.